How's it going, everyone? Welcome to another video lecture for critical reasoning. In this video, we are going to start focusing on and talking about inductive reasoning. So we are going to be moving away from deductive logic, which we spent the last few weeks working on. We laid a foundation to understand how to evaluate deductive arguments, looking at sort of the basic fundamentals for natural deduction and thinking about things like truth values and creating truth tables to help evaluate validity. Now we're going to be turning to a completely different kind of reasoning, a different form of reasoning that we call induction. We spent a little bit of time previously kind of explaining what inductive reasoning amounts to, some of the key terms. But now in this video, we're going to get into the weeds and dig into all of that in much more detail. So let's begin by just making sure that we understand the topic. Right. And we're focusing on chapter 5 from the Vaughan textbook. Largely, this is going to be following exactly what Vaughan does in this chapter, the chapter on inductive arguments and statistics, statistical reasoning as well. So remember from previous discussions, deductive arguments are the sort of arguments that aim at establishing some sort of conclusive sort of conclusion, right? So we get a kind of logical necessity where if the premises are true, then that necessitates the truth of the conclusion. This guarantees that the conclusion is true. It could not possibly be false if all of the premises are true. So in that sense, deductive arguments are called truth preserving, right? The truth of the premises are preserved in the conclusion if it's a valid form of reasoning. But now with inductive arguments, we are no longer aiming at some sort of logically conclusive support for the conclusion. Rather, our goal, our aim here is to give some sort of statistically likely or probable conclusion, right? So if the premises are true, if we have reason to accept the premises, then that doesn't guarantee the truth of the conclusion. Rather, it gives us, a high probability that the conclusion is true. So these arguments are described in terms of providing probable support for the conclusion, or they're probably going to preserve truth in the conclusion. Now, recall some other terms that we introduced previously in previous modules. That the notion of a strong inductive argument is one where the conclusion is highly probable. Right? If the premises are true, then the conclusion is very likely. That's going to count. That's what we're going to call a strong argument. A weak argument, a weak inductive argument, however, is one where the conclusion is not very likely. It's not probable. So in these sorts of arguments, we don't have good reason to accept the conclusion. But if it turns out that all of the statements in the argument, all of the premises, are in fact true, and the argument is strong, then that sort of an argument is called cogent. Right. So it's going to be a strong argument where we have high probability of the truth of the conclusion. And it really is the case that all of the premises turn out to be true. That's going to be called cogent. And that's sort of the parallel of what we have with regard to deductive reasoning. That's the parallel to a sound argument. So you can think of cogent and soundness as being very similar in that regard. But remember, soundness for deductive arguments tells us that the truth is guaranteed if it's both valid and sound. Whereas with regard to inductive arguments, the conclusion is not guaranteed. It's highly probable. And if the premises are true, then it would be cogent. Now, another point that I want to call to your attention is the fact that these sorts of arguments are very common, right? They're used all the time throughout your daily go of things, as well as in the sciences. So it's very likely that you'll come into contact with some form of inductive reasoning throughout your daily life. These are very powerful forms of argument, different forms of reasoning. That's because they go from what we know, something that we already have knowledge of. Maybe we've collected some data, maybe we've made some observations, or maybe we've performed some sort of experiment. Maybe we've gone out and done some research of some form. So we've got this information, and so we go from what we know to something we don't know, right? So we are arguing from evidence to something, a conclusion that goes beyond the evidence. So here's a kind of a toy example that I like to use to illustrate this point. Suppose that we begin with the premise that says, every Catholic church that I've ever been in has had a statue of Mary in it. And then let's say that I've lived in lots of different places and I've gone to many different Catholic churches, right? So this includes Kansas City, San Antonio, Topeka, Lawrence, Omaha, Lincoln, maybe even Paris, France. And in each of those cities, there was a Catholic church that had a statue of Mary in it. Right, so that's all the information that I've had. I've made a bunch of observations in every Catholic church I've ever been to, and each of those churches has a statue of Mary. Therefore, I conclude that the next Catholic church that I go into will probably have a statue of Mary. Now, notice here, I'm going from the information that I have, right, the observations that I've made, I'm going from that evidence and I'm taking it beyond the evidence. I'm going beyond the observations that I've made. I'm going from what's known to what's unknown. And here, it looks like it's probably a fairly good argument because most Catholic churches do seem to have a statue of Mary. But nonetheless, it could be the case that the next Catholic church I go into, maybe it doesn't have a statue of Mary, right? I can certainly conceive of a situation. I can imagine a case where the conclusion is false, even though all of those premises are true. And so that tells me that it's inductive reasoning, because it's, first of all, it's not valid. Nonetheless, it's still very likely, right? It's still highly probable, even though I don't have a guarantee of the truth of conclusion. The conclusion still seems very likely. Okay, so that's the toy example. We'll go through several other examples throughout these videos, but I also want to make this further point, again, following what Vaughn tells us in the chapter. We're going to pay attention to two basic forms of inductive arguments. There are other ways of thinking about induction. Later on in another module, we're going to look at scientific reasoning in more detail, and we're going to look at abduction or abduction. And I think there's a case to be made that that kind of reasoning is a form of inductive reasoning. But for this particular module, we're going to focus on just two specific kinds of inductive arguments. First, we're going to consider what's called enumerative induction. Enumerative induction involves arguments that reasons from premises about individual members of a particular group or particular instances of some particular, generalization or some universal. And then we go to a conclusion about the whole group. We reason from the particular instances to the whole thing. And we begin with observations and then end with some kind of generalization or universal claim. Right, so that's enumerative induction. We're enumerating based upon specific instances to a more general conclusion about the whole group. There's also a form of inductive arguments that's called analogical induction, and this is sometimes called argument by analogy. Right, so an argument by analogy or analogical arguments, these are arguments that take two or more things that are similar in some respects, and we create a kind of an analogy, and then we conclude that there must be that there must be something that's similar in other respects too. Right, so we'll look at different examples of that form of argument, and we will also consider how to evaluate that kind of argument. All right, so now with regard to enumerative induction takes the following basic kind of form. It says X% of the observed members of some group A have a property P. Therefore, X% of all members of group A probably have property P. Right, so we're being very open in general here. I'm not stating specifically what percent or what the group is or what the property is, right? So we can plug in for these variables pretty much anything we want. So we'll go through some examples in order to illustrate that point. But let me make clear some of this terminology here at the beginning. First, the target population, that's going to be the whole collection of individuals in question, right? It's the whole group. It's the whole the whole entire collection of individuals. The sample members, or sometimes we just say the sample, these are going to be the observed members or the individuals in the target population. And when I say individuals, I don't necessarily mean people. I just mean the instances that are being observed. Then the relevant property of the group, or sometimes we'll just say the property in question, that's going to be the property that we're interested in. It's the property that we are attributing to the individuals in the group, that is the sample members, and we're saying, well, look, if these sample members have this property, then the whole group must have that property as well. So here are a couple of basic examples that we get from the chapter. All right, so the first one says 40% of the observed pickles from the barrel are exceptionally good. Therefore, 40% of all the pickles in the barrel are probably exceptionally good. So notice in this first example, we've got a very specific target group. What is the target group? It's the pickles in the barrel, right? That's the whole group. And then the sample size is going to be the observed pickles, the pickles that we've actually come into contact with in some regard. And then what is the property? The property here is going to be being exceptionally good, right? So we're saying that, well, 40% of the whole group had this property of being exceptionally good. Therefore, 40% of all of the pickles that happen to be in this barrel do have this property of being exceptionally good. So that's, again, going from the instances that we have observed to the instances that we have not observed, namely all of the pickles, 40% of all of the pickles. Another example here is all corporate executives that Jacques has worked for have been crooks. Therefore, all corporate executives are probably crooks. All right, so in this case, what is the target? What is the sample? And what is the property under consideration? All right, so the target is going to be the corporate executives that we're considering here. The sample is going to be the particular corporate executives that Jacques has worked for. Right, so the whole group is all corporate executives. The sample is going to be just the corporate executives that Jacques has worked for. And then what is the property that is under consideration? Being a crook, right? Because we're saying that therefore all corporate executives are probably crooks. Finally, the third argument that we get from the text here says, all right, well, notice that this particular argument has a typo. It should say birds rather than births. So I'll make sure to fix that for you. But the argument, either way, says all of the blue herons that we've examined in many different sites in the nature preserve, which is about 200 birds, not births, have had birth defects. Therefore, most of the blue herons in the nature preserve probably have birth defects. All right. So, what is the target group? What is the sample, and what is the property under consideration here? Well, the target group is going to be blue herons in the nature preserve. Notice that that's not just blue herons everywhere in the world, but rather it's the blue herons in the nature preserve. All right, so then what is the sample size? The sample size is 200 of these birds, right? So there's a whole lot more than 200 birds in the nature preserve, but we've observed 200 of them. And then what is the property under consideration? It's having this kind of birth defect, whatever that happens to be. Right. So again, we're going from a particular observation that we've made, some evidence that we've collected, and then we're going beyond the evidence to this more general conclusion about all of the blue herons in the nature preserve. All right, so that's a basic sort of introduction to what we mean by enumerative induction, but there's a lot more that we will need to get into, and we'll do that in the next video.